Hi, I'm Mrs. Schroeder, and we are going to talk today about the science of chemistry. This is the first chapter, kind of sets a stage for what do we want to know and what are we going to learn the rest of this year. So this first section is titled What is Chemistry? Some objectives that we're going to cover today would be talking about ways that chemistry is part of your life, looking at common states of matter, physical chemical changes, and some observations that suggest chemical changes have occurred. If you look at these pictures, what do you notice about all of these? They're all considered chemicals. Okay? Things like aluminum foil, cotton, sugar, medicine, water, and even metal. All those things are considered chemicals. So, what is a chemical? You might want to pause just to write this down. Chemical is any substance that has definite composition. It's always the same stuff. It doesn't matter what shape it is or where it comes from. Again, you need to know this definition. Aluminum. When you hear aluminum, what do you think of? Probably aluminum foil, like this. Are there other shapes aluminum can come in? Yes. It can be cans. It can be your alloy wheels on your sportier cars. It can be just rods and shapes over here. These are all things that are aluminum. It's the same substance no matter what shape it's in. Now it's important for us to understand. If we want to understand what a chemical change is, we have to understand what a chemical is first. We do know you guys have probably all followed recipes. You've probably all made cookies or at least eaten cookies. And you might follow a recipe that talks about having flour, sugar, baking soda, vanilla. We're going to add all that stuff to our cookies. What are those things? Well, they're chemicals. You're eating chemicals. Sodium chloride is a salt. It's going to look like these green and purple dots. And we'll talk about why they are different sizes, how they're arranged. We'll learn that as we go through the year. Baking soda is actually called sodium bicarbonate. It has a real chemical name and a chemical formula, NaHCO3. Again, we're going to learn what those letters mean and how to use those. Sucrose is another word for sugar. Sugar is C12H22O11. And, of course, there's vanilla, which is C8H5O3. It's another form, and it looks very different. And all of these chemicals you're going to see look very different. But they're still all chemicals. We use reactions to change materials from one thing to another. Reactions do take place all around us every day. I want you to pause the video here and see if you can think of examples of chemical reactions. We're going to talk about this in class, so I want to see if you can come with some good examples for me. Matter is another term for particles. If it's made of particles, it's matter. A chair is made of particles, it's matter. Light is not made of particles, it is not matter. The properties of different materials depends on how the particles are arranged, what they are and how they're arranged. So we have states of matter. I'm sure you've covered this in junior high, in grade school, solids, liquids, gases, and even plasma. And we see pictures here. Solid ice, liquid, and even a gas. Those are things that we see. We call those macroscopic things. Things that we can see without looking at something else with our eye. Microscopic, then, are things that you could see if you could see individual atoms. We can't see atoms. They're very, very tiny. Again, we'll talk about that later in the year, how tiny they really are. We can't see them, but they are packed differently. And this picture shows you water, when it's a solid, is arranged in very tight rings. You can kind of see these ring structures, and there's empty space in between. That's why ice floats, because there's empty spaces that make it kind of buoyant. Liquids are packed pretty tightly also, and they can kind of slide past each other. Okay, so they have these particles that are kind of moving around and sliding past each other. Gases are very wide open, a lot of space in between these particles. They are moving, they're bouncing off each other, and floating all around. We're going to get into changes of matter, and we're going to go through some examples in class. I'll do some examples and demonstrations you're going to see in class tomorrow, so see if you can think of examples of these changes. Look in the books if you can come up with some examples. Physical changes, though, are things in which, this is important, the identity does not change. It's the same material whether it is in a different state. Water is still H2O whether it's a liquid or a gas. If I take a paper and rip it into pieces, it's still paper. It's just in a different form. It doesn't mean it's irreversible, it just means that it is in a different form. Physical change. Chemical changes then are things that have a new substance, have a new identity. And these are things that change during the change, they become a new substance. The atoms get rearranged. Again, we're going to talk about these. I'll have some demonstrations for you to do in class. We're going to talk about evidence, what we see. The book had a picture for you if you look at it, and it shows you a couple of reactions. Acetic acid and vinegar, what do we see? We see bubbles. That's the thing we call evidence. This next one, they're mixing two materials and they see this yellow solid, okay, called a precipitate. That's evidence, okay. Heat and light when something is burning. Change of color, okay, colorless to pink. Change of color would be what we call evidence. That's going to be very important as we start looking at our investigations and we start talking about how to understand if something has changed, is looking for evidence. So that's all for this lesson. Make sure you're taking your notes, summarize this, and we'll talk about this more in class. Signing off for now.